Alright, let's take a look at the concepts of logarithms. Now, before we get into the definition of logarithms here, let's take a look at a problem that I want you to find the inverse function of. So let's suppose I give you the function for the exponential function. Let's say let's say f of x. So let's let f of x be, let's say, 2 to the x power, right? And I want you to find the inverse. Find the inverse function of that. All right, what is the inverse function of 2 to the x? All right. Well, then we can use our standard procedure we had last time on that, right, on finding inverse functions. Right. First, let y be the function. All right. Then we're going to switch x and y. So so y becomes x and x becomes y. And then you're going to solve for y, as we've done in the past. All right. Now, the only problem here, though, is that there's no way for us algebraically to solve for the variable y, because y is in the exponent. There's no way I can get the y down here and isolate the y variable in terms of x. So it's impossible algebraically at this point to solve for y. Right? So we need a definition of how we can solve for y here. And that definition is going to be the logarithm, the log here. All right? So here's how we're going to define this then, right? So in other words, first of all, let's understand what is this equation saying. This equation is saying that to get x, you need to take 2 to the y power, right? So y is the power you have to take 2 to get x, right? So let me say that y is the power to take 2 to get x. All right, so y is the power to take 2 to get x. All right, so that's what y is. All right, y is the exponent. All right, now then we're gonna give a definition here. So here's a definition of how we're gonna solve for y here. Y then is equal to the logarithm base 2 of x. So y is equal to log base 2 of x. So this is the base. Since the base is 2 here, right? The power, the base here, right, is 2, and y is the exponent. So this logarithm is, and y is the exponent. So this whole log is the exponent. So we can think of logarithms as exponents, basically, right? Because that's what they are, right? So the exponent is basically the log, right? Now let me give you the formal definition. Then let me go and clear out the screen. Actually, before I do that, then so the inverse function is of 2 to the x is log base 2 of x. To finish this out, but let me give you the official definition. So here's the definition of log. Again, basically think of logarithms as exponents. Logs are exponents here. Bottom line. All right. So we say that y is equal to log base a of x if and only if. So what's the base here? Well, the base is 8. All right, and again, y is our exponent, and y is this whole logarithm. All right. So if and only if what? A to the y power is equal to x. All right. So again, the way we convert the log statement, log equation, into an exponential equation is using this translation. Base to the exponent is equal to whatever is inside the logarithm that we're taking of. All right. So again, we have to work with this definition a little bit to get a feel for it, right? So keep these two equivalencies in mind in terms of definition here. All right. Again, think of logarithms as the exponent. So in other words, if I give you this problem, let's say here, let's write let's say 2 to the 5th power equal to 32 as a log statement, or as a log equation. All right, as a log equation. So how do you do that? Again, the exponent is the logarithm. So this is my logarithm. All right, the 5. All right, 2 to the 5th is certainly 32. Right. So how do we write this then? Well, then the exponent is going to be my y. Y is your exponent here, right? So this is the y. Another way of looking at it. So in other words, 5 is equal to, so y is equal to what? Log base ax, right? What's the base? The base is 2 again. So log base 2 of what? Well, the only number missing is what? The 32. So log base 2 of 32. In other words, what this statement is saying is that 5 is the power I need to take 2 to get 32, right? Can we see that from the original equation? 5 is the power for us to take 2 to get the number 32, right? Let's try another one. Let's write 5 cubed equal to 125 as a log equation, as a log, I'll just say. All right. Again, what's the exponent again? 3, right? So this exponent is my logarithm. So in other words, 3 is equal to what? Log. What's the base again? This time the base is what? 5 this time, right? 5 cubed is 125. So 3 is the power. 3 is the power I need to take 5 to get 125. So 3 is equal to what? Log base 5 of 125. All right. So this is how we convert the exponential equation into what? A log equation. All right. Here, let's do one more. Give us a better feel. Let me go and clear out the screen. All right. How about let's see. How about let's try this one. How about let's look at 9 squared being 81. Certainly, right? We know about that. The perfect squares, right? So let's write that as a log again. All right. So again, the log is always the exponent, right? So 2 is the log. 2 is equal to the log, in other words, right? So this is my logarithm. All right. And I mean, and this statement is saying what? 2 is the power I need to take 9 to get what? 81. So 2 is equal to log base 9. The base is 9 here, right? Of what? 81. All right. So again, converting exponential equations to logs does take some practice, but it's based on that equation I wrote earlier at y is equal to log base a of x. If IFF stands for if and only if, right? If and only if what? X is equal to a to the y power. All right. So again, that's the exponent, that's the base, and it's equal to x. Okay. All right. Anyways, let's go backwards now. Suppose I give you a log equation. Can we come up with an exponential equation? That's a little bit easier, right? So let's take a look at this one. Let's write something like let's try this one. How about log base 6? Log base 6 of 36 is equal to 2 as an exponential equation using this definition above. Exponential equation. All right. So write this log as an exponential equation. First of all, what is this log saying? This log is, so first of all, what's the exponent? Well, the log is the exponent, right? So log, and then this log is equal to what? 2. So 2 is my exponent. All right. What's the base? 6. B-A-S-E. Sorry about that. Sketchpad's acting up a little bit. But again, this equation is saying what? 2 is the power I need to take 6 to get what? 36. Certainly 6 squared, right? 6 squared is equal to what? 36. All right, can we see that? Let's do another one. What about something like, let's see, how about, see, let's write log base, let's write log base, well, this time I'll leave the base off. All right, let's talk about this. Write log of, let's say, 1,000 is equal to 3 as an exponential equation. As an exponential equation. Okay, so I'm running out of space here. But what's the base, you may ask? So I left off the base. Can we see that? Log of 1,000 equal to 3. All right. Now, if the base is left off, all right, if there's no base written, the implication is the base is going to be 10. This is called a common logarithm. This is called a common logarithm. Base is equal to 10 in this case. So in other words, we can put we can write a 10 down here. So this equation can be written as log base 10 of 1,000 equal to 3. Certainly 10 what? 10 cubed is equal to 1,000. We can see that, right? 10 cubed is equal to 1,000. So I've converted to what? The exponential equation here. 10 cubed equal to 1,000. If you're converting this. So if the base is not stated, it's implied to be what's called the common logarithm or base 10. In fact, on your calculator, there's a log button on your calculator, and this log is base 10. So if you punch in log 1,000 on your calculator and hit the equal sign, it should give you a 3. All right. Let's go and clear out the screen. Let's do another one. Let's take a look at log of, let's say, 100,000. All right, log of 100,000. So again, what's the base? Base is 10. Right. So this implies log base 10 of 100,000. All right. Again, punch out your calculator. Use the log button on your calculator and punch in log 100,000 and hit the equal sign. So punch in log 100,000 and then hit the equal sign. All right. It should give you a 5. So log base 10 of 100,000 is equal to 5. Because 10 to the 5th power, 10 to the 5th, again, this is the exponent, right? 5 is the exponent, 10 is the base. All right? Yeah, 10 to the 5th power is certainly 100,000. All right? So again, know how to convert log equations to exponential equations. Right? That's not too bad. All right? In fact, let's do a few more of these. Right? So we have the log button that we can use. Right? We also have what's called the natural log button. So let's take a look at that one as well. Let's look at the ln button here on your calculator. This is called the natural log. This is natural log. Natural log button on your calculator. Natural log, ln. All right. And what's the base of that? The base is that number we said from some time ago is the irrational number e. The base is e. In other words, if I want you to find ln of let's say 1,000, it's not going to give you 3 with the log button, because the base is 10, right? 10 cubed is 1,000, but not natural log. The base is different. The base is e this time. This will give you a decimal number on your calculator if you punch in the calculator using this ln button. In fact, punch it in. I'm going to punch it in right now. All right. So hopefully you should get this then, right? So let me punch it into my calculator. 1,000 ln. All right. I'll round it off to 3 decimal places. 6.908. So this is roughly 6.908 on my calculator. All right. So again, that because if you take e to the 6.908 on your calculator, it should be roughly 1,000. Again, converting it back. Again, think of ln 1,000 as what? Log base e, because that's the base is e of 1,000. All right, and you should get 6.908 if you punch it into the calculator using the ln button. All right. So let's try another one here with the ln button. We're going to clear out the screen. Let's punch into the calculator ln. Let's find ln of, let's make it, let's see here, 25,632. 25,632. What is that in the calculator? So let's punch it in. 25,632, 25,632 ln on my calculator. So I'm going to get roughly what? Let me round it off again. I'll go 4 decimal places here. 10.1516. 10.1516. 10.1516 on your calculator. Again, to double check that, just take e to the 10.1516 using the same feature, same ln button, except you have to hit the shift key or the second key, typically for most calculators, to get this e to the x feature. All right. Take it to this power, and it should give you roughly 25,632. All right. Now, if you punch in log of 25,632, it'll give you a different answer because the base is what? The base is not e. The base is 10 now, right? You're going to see this feature on your calculator. The base is 10. So if you punch in using the log button here, right? Usually this feature is above the log button, this 10 to the x feature. All right. You'll get roughly what? Let me punch it in. 25,632 again. And I'll hit the log button this time. And again, I'll round it off to 4 decimal places. 4.4088. 4.4088. 8 on my calculator. Again, if I try to check my answer, then I have to punch in 10 to the 4.4088. It should give me approximately 25,632. Okay, so again, first of all, what do these numbers give us? These are exponents. Remember, the 10.1516, the 4.4088, these are exponents. This is saying that we have to take e to the 10.1516 to get this 25,632. This is saying we have to take 10 to the 4.4088 to get the 25,632. It depends on the base, all right? So your calculator understands two different bases, base e and base 10. All right, we'll talk about other bases. Let's talk about other bases. Then. Suppose I want you to find log base 2 of, let's say, 128. Okay, log base 2 of 128. Sorry for the scribble here. Cross it off. So the base is 2, and in other words, this problem is asking us, and logs are what? Exponents, right? This problem is asking us 2 to what power? So the question is 2 to what power? So h to what power is, or 2 to what exponent is what? 128. All right? 2 to what exponent or what power is 128? Well, to answer that, you can let it equal to some number n. Let's let log base 2 of 128 equal to some number n. All right? Again, earlier we gave a definition of logs to exponentials, right? How do you convert this? Well, this is my exponent, this n, all right? And this is my base, 2. So we can convert this to 2 to the nth power is equal to 128. Can we see that? Now to solve this equation, I just have to figure out 2 to what power is 128? Right? Well, if I play with my calculators a little bit, you're going to see that 2 to the 7th power is 128. So the answer is going to be 7 in this case. Right? So log base 2 of 128 is equal to 7. All right? Let me conclude it by writing. So log base 2 of 128 is equal to 7. So 7 is the answer we're looking for. Let's try another one. Take a look at this one here. How about log base 3 of 81. Okay? In other words, 3 to what power is 81? Okay, so again, this is asking us 3 to what exponent or power is 81. Alright? So again, let it equal to n. Let's let log base 3 of 81 equal to some number n. N is my exponent, right? So again, convert it to an exponential. So the conversion is going to be what? Base to the exponent, 3 to the n, equal to what? 81. Oops, my sketchpad's acting up here. Let me write 81 carefully there, alright? So ignore this mess right here, sorry about that. But look, can I write 81 as a power of 3? Yes, I can. It turns out that 3 to the what? 4th power is 81. So therefore, my n is equal to 4 as my answer. Right? So log base 3 of 81 is what? Is 4. 3 to what power is 81? So the answer is what? 4. Alright? So again, we can use this technique to find the log of other bases. So our calculator only knows what? Base E for ln button. You have this button here. And you have the log button, base 10. Oops. Sorry again, calculator, the sketchpad acting up. Alright, log button, base 10. Alright, so again, ln is base E, and this is base 10. For the common logarithm, natural logarithm. Alright, anyways, so we can use this technique if the number inside is a perfect power of this base. 81 is, earlier example I gave you, 128, is also, right? So now, in terms of power of 2, right, from the earlier example. But what about if I give you some strange number that cannot be written that way? In other words, what if I give you a problem like this? Let's take a look at log base 3 of, let's say, 195, for example, right? So you may say, okay, well, I'm gonna let this be n, just like I did earlier, right? And then converting it 3 to the nth power is 195. Problem is, I cannot get 195 to be a power of 3. 3 to what power is 195? We don't have that, at least in terms of an integer power. So this actually is going to be a decimal answer, right? Now to answer this question here, right, we need what's called a change of base formula, because I can't solve this directly like I did up here with 81. 195 is a different animal, right? Different number. I cannot write 195 as 3 to an integer power. 81 I can, because 81 is what, 3 to the 4th, right? Can I do that with 195? I cannot. So therefore, I need another technique. I need what's called the change of base formula. So here's an important formula for us to use, because we're going to need this to find something like this, right? Log base 3 of 195. In other words, 3 to what power is 195? It's going to be a decimal answer here, because 195 is not a perfect power of 3. All right. Anyways, what is this change of base formula? Well, we can change the base to only two things on our calculator, right? Either to what? Base e, since we have this ln button on our calculator, or base 10, the common logarithm, since we have the log button on our calculators. So let me write it this way. Let me write a simplified version of the change of base formula, different from your textbook, right? Because we're just going to use these two buttons anyways, right, on our calculators. So let me say that if you want to find the log of base of some base of some number, let's say some number, let's make a k here, if you don't mind, right? Log base a of k. Then we can let that be, the change of base formula can be used to change it from base a to one of these two bases. If you want to use base e, you use this ln button, then it's going to be ln of k divided by ln of a. Okay, so you will punch that into the calculator. Or you can also use this common log button on your calculator, which is base what? Base 10. Then it's the same thing, really. Log of what? K over log of a, base 10. So this is using the log button on your calculator. This is using the what? ln button on your calculator. All right? So take your pick. Either one works. Just be consistent. ln and ln, log and log. Don't mix and match. All right? So in other words, going back to our problem here, I cannot solve it using this technique. So I'm going to use the change of base formula. So log base 3 of 195. I'm going to write this. Let me use the ln button here. Then this is going to be equal to, let me set the right again, log base 3 195. This is going to be what? ln of 195. Since my k is, think of the 195 as my k. Think of the a as 3. So ln of 195 divided by ln of what? 3. All right. Now let me punch down to the calculator in one shot and round it off to a few decimal places. All right. So on my calculator, this gives me roughly what? Let me punch it in. So 195, all right, 195 ln, all right, divided by 3 ln equal to roughly, I'll just round it off a little bit here, 4.79969. Okay, so roughly 4.79969. So I'm going out to 5 decimal places here. Again, the more we go out, in terms of decimal places, the more accuracy we get. All right. In other words, 3 to the 4.79969 power is 195. So to check this answer that you got right here, using the change of base formula, right? Using this change of base formula right here, you simply take 3 to the 4.79969, and it should give you roughly 195 if you punch it into the calculator correctly using the power button, right? Power feature we talked about earlier. All right, let's try another one. So keep this change of base formula in mind. Let me clear up the screen. All right, let's go ahead and find log base. Let's say base 8. Log base 8 of 5,631. All right. So 8 to what power? So again, logs are powers, right? Logs are exponents, right? So this is saying 8 to what power? So this is saying 8 to what power is equal to 5,000 or 5631, 5,631. So let's figure out what that is. So again, let's use the change of base formula. This time I'm going to use the common log button. I'm going to use the log button instead of the ln button. All right, but again, either one, it should get the same answer either way. Just be consistent. Use ln, stick with ln. Use log, stick with log. All right. So what's that going to be if I use that? Then this is going to be what? Log of what? 5631. So this is basically strictly a calculator problem. Log of what? 8. All right. Let's see what that gives me on the calculator. So 5631 log divided by 8 log equal to. So roughly 4.153 if I punch in the calculator. I'm just going to cut it off at 3 decimal places. All right. So in other words, 10, no, not 10, but 8. 8 to the 4.153 power is roughly 5631. You can check that in your calculator. All right. So again, get some practice with the change of base formula. You can either use the log feature or the ln feature. Once again, I'll just repeat it here. Log base a of k, change its base to ln. That'll be ln of k over ln of a. There's an a there, sorry about that. Or change it to the common logarithm. It would be log k over log what? A. So either way, take your pick. We have both these buttons on our calculator at our disposal. All right. So here I used the log. Last time I used the natural log. So either way, it's going to work out. It's always log of this number inside divided by the log of the base on the bottom. Either ln or log, that is. All right. So not too hard to remember. I think if you get some practice, it should work out. Let's take a look at another problem. Let's take a look at the solving for x in this equation using the log definition we talked about earlier. Let's solve something like solve this equation. Log base 5 of x equal to let's make it equal to 2, for example. Let's solve for x. All right. Well, solve for x is not hard at all because we can convert this log to an exponential. Remember, the log itself is the exponent, and this log is equal to 2, so 2 is my exponent. Right, 2 is the exponent. So, and again, what's the base? 5. So therefore, we see that 5 what? Squared, base to the exponent, is equal to whatever's inside the log, equal to x. So x is simply equal to what? 25. Okay? Not too bad at all. Let's try another one. Let's go and solve log base 7. Log base 7 of x equal to, let's say, 1 over, not 1 over, let's make it negative 2, I want to say. So again, cross that off. Sorry about that, guys. Log base of x equal to negative 2. So again, convert it to an exponential. So here's the base. 7 is the base. Negative 2 this time is the exponent. So this will be what? 7 to the negative 2 equal to what? X. All right. But what's 7 to negative 2? If you recall from the negative exponents, right? You bump it down to make it positive. So this is 1 over 7 squared, right? Which is going to be what? 1 over what? 49. Okay, so 1 over 49 is the answer we're looking for. So x is equal to 1 over 49 is what I'm trying to say here. Sorry, I ran out of space down there, but hopefully you can see that. All right, here, let's do one more. Here, I'm going to clear out the screen. All right, what about log base 5 of x equal to negative 4? Okay, so again, take the base to the exponent. Again, this is my exponent. The negative 4 is my exponent. All right, so this is my base. Once again, all right, convert it to an exponential. So 5 to the negative 4 is equal to x. So x is equal to 1 over 5 to the 4th if you convert it to a positive exponent. And what's 5 to the 4th on our calculator? 1 over 625. 5 to the 4th is 625. So final answer is going to be x equal to 1 over 625. Alright, so that's the solution. Okay, not too bad here in terms of working with logs and their definitions here. Alright, now let's finish out by giving you 3 important properties of logarithms. So let's look at three important Sketchpad's acting up a little bit. 3 important properties of logs. Alright? Of logarithms. Alright? First one is called the product rule. Let's see why. So let's look at the product rule. Product rule for logarithms. Right? It says that log base A of x times y, so if you take a log of a product, you can break it up into a sum. Log base a of x plus log base a of y. Alright, can we see that? Log base ax plus log base ay. So y here, sorry to write so close to the edge. Alright. Second one here, hopefully I won't get too close to the edge of this one. Let's look at the quotient rule. We'll put these two rules in play in a moment in terms of an example for you. But if you take the log of a quotient, x divided by y, alright, then that's going to be the log base a of x plus the log base a of y. Not plus, I'm sorry about that. I meant to say minus there, because you remember with exponents, right? If we divide two exponents, right, two exponentials, we subtract the exponents. If we multiply two exponentials and logs are exponents, right, we add the exponents. That's the reason for that. So this should have been minus. Sorry about that. I've kind of lost my concentration a little bit on that, but yeah, minus here. Sorry about that, guys. So again, log base a of a quotient, you subtract the two logs, minus here. All right. Sorry about that again. All right, let's look at what's called the power rule or the exponent rule. All right. If you take log base a of x to the n power, then you can bring that n to the front of the log. So this is equal to n times log base ax. Okay. So keep these three properties, key properties, and there are a few others in your text as well. But these are the three properties I want to get at here to finish out. Now let's use these three properties to either expand a logarithm or contract it. Here's what I mean by that. Let me go and clear out the screen. So keep these three properties in mind. Let's say I want you to expand the following logarithm. Let's expand the following log. Break it up into smaller logs. Let's say log base 2 of let's see, how about of this product here, w cubed x to the 4th, y to the 7th power, right? Expand that logarithm, okay? Well, this is a product, is it not, right? We're multiplying these three things, right, inside the parentheses. So we can break it up into a sum. So this is equal to log base 2 of w cubed plus, right, sum, right, log base 2 of x to the 4th plus log base 2 of y to the 7th. Can we see that? Using the product rule we talked about earlier. If it's a product, you can break it up into a sum. Bottom line. Now, what about these powers? 3, 4, and 7. Well, by the power rule, we can bring them out to the front. Can we see that? Front of the logs. So in other words, this final answer is going to be what? 3 log base 2 of w plus 4 log base 2 of x plus what? 7 log base 2 of y. So this is the expansion of that product inside the log. Can we see that? From here to here. This is called expanding it out. Let's do one more. Let's go and expand something like this here. What about, let's try this one here. Let's look at, how about ln of, let's see here, ln of w to the 5th, y to the 6th, so 6 right there, sorry about that, divided by x to the 9th. Alright, let's go expand this natural logarithm. This involves a product on top and a quotient on the bottom. So you're going to use both what? The product rule and the quotient rule to do this, right? So let's go and do that. So first of all, look at this as a quotient, right? The top is what? W to the 5th, y to the 6th, the bottom is x to the 9th. And you're dividing them. So we can break it up into what? Subtraction, right? This is the quotient rule. Break it up into minus. So this is equal to ln of w to the 5th, y to the 6th, alright? Minus, alright, because you're dividing these guys, alright? ln of x to the 9th. Does that make sense? Alright? But look at this product. That's a product there, right? So we can break it up into what? A sum. So this is equal to ln of w to the 5th plus ln of y to the 6th, alright? And just bring that down, minus ln x to the 9th. Now, can we see that? So we break up this product into that sum. Alright, anyways, how do we finish it off again? Use the power rule to finish out. 5 comes out to the front. 6 comes out to the front for ln y, and 9 comes out to the front for ln x. Final answer will be 5 ln w, natural log w, yes, an n there, sorry about that, ln w plus 6 ln y minus 9 ln x. So final answer, if I expand that quotient there, it's going to look like this. Alright, can we see that? Now let's go backwards. If I give you, if I start with this guy down here, can you go all the way back to 1 log from the very beginning? That's called contracting the logarithm. Let me go and clear out the screen and go backwards. So let's go backwards here, right? So let's say I want you to write as 1 logarithm. Write as 1 log. Alright, for the following. Let's say we have something like 3 log base 5 x minus 2 log base 5 y minus, let's make it minus 9 log base 5 z. Alright, so 3 log base 5x minus 2 log base 5y minus 9 log base 5z. Let's put it together as 1 logarithm. Alright, base 5, of course. So how do we do this? Well, work backwards. Now when you work backwards, you want to start off with the power rule. So bring these coefficients 3, 2, and 9 back up to the top for these powers. So 3 goes back on the for the power of x here. Treat this as a positive 2, not negative 2, right? Because you can use the quotient rule to account for this minus sign. But yeah, let's go ahead and put that 2 back to the y and the 9 back to the z. Can we see that? So in other words, so the next step is going to be log base 5 of x what? Q minus log base 5 of y squared. Can we see that? Minus log base 5 of z to the 9th. All right, does that make sense so far? All right. Now, how do we treat these differences? Well, use the quotient rule. So let's just go from left to right. So for the first two, let's handle 2 at a time, 2 logs at a time. You're minusing these 2 logs, you can divide these 2 quantities using the quotient rule. Can we see that? In other words, I can write the first 2 logs as log base 5 of x cubed, right, over what? Y squared. Does that make sense for the first 2? And just bring that down, minus log base 5 of z to the 9th. So far so good, right? Now, what about this difference here between these 2 quantities? Well, again, minus means divide, right? Apply the quotient rule again. This one's a little bit more complicated because here's what it looks like. You have log base 5, big parentheses here, x cubed over y squared on top, all over what? Z to the 9th on the bottom. Can we see that? All right? That's a little more complicated because this thing here is a complex fraction, right? Let's look at this complex fraction aside of our paper, for example, right? Because I need to simplify this. This is not fully simplified yet, right? Because this is x cubed over y squared all over z to the 9th. But that's equal to x cubed over y squared times 1 over z to the 9th. Is it not? If you're dividing by z to the 9th, just multiply by the reciprocal of it, right? So really, this complex fraction simplifies to just what? X cubed over what? Y squared and z to the 9th. Can we see that? So this thing here should be rewritten, this complex fraction should be rewritten as this fraction here. So final answer should be log base 5, if you're writing this whole thing as 1 log, log base 5 of what? X cubed on top, x to the 3rd on top, and y squared and z to the 9th on the bottom. Final answer. Alright, so pretty tough problem to go backwards and put it together as 1 log. Let's go and try another one. Let me go and clear out the screen. How about this one? How about, let's take a look at 5 ln x, let's see here, minus 2 ln y plus 3 ln z. All right, let's go and try that one. All right. Then how do you write this? That's as 1 log. Write as 1 log. Contract it as 1 log. Write as 1 logarithm. All right, as 1 ln, that is. So again, let's apply the power rules. Bring the 5 back up for x, 2 back up for y, 3 back up for z. So we're going to get here ln of x to the 5th minus ln. So apply the power rule first to work backwards. Ln y squared plus ln of z cubed. Can we see that so far so good? Now let's use the quotient rule and the product rule here, right? Minus think division, plus think multiplication. All right. So let's do that. So this is going to be ln of what? X to the 5th over what? Y squared. Can we see that? Since we're subtracting these logs, you can turn that into a quotient, right? Plus ln of z cubed. Well, you're adding these, so what? Think multiplication. So this is going to be ln of x to the 5th over y squared times z cubed. Can we see that? But that means z cubed is is what? On the top, isn't it, right? So final answer will be ln of x to the 5th z cubed over y squared. Alright, so this is the final result that we should come up with here. Alright, so practice using these properties to contract the log, work backwards to write as one log, or to expand it back out. So if I give you this ln from the beginning, you should be able to give me this result right here at the end. Alright, that's called expansion here, right? Alright, so again, 3 rules to keep in mind again: product rule, quotient rule, and power rule. And what else? Change of base formula as well, and a few, and of course the key being the definition of a logarithm, right? Logarithm. Think of logs as exponents, right? It's the power you need to take a base to get the result inside the log. All right. Anyways, let's go ahead and finish out with some problems I want you to work out and post into Blackboard. So let's go and do that. Let me go and clear out the screen here. So number 1, I want you to evaluate the following logarithm. All right, so let me get my sketch pad right here. Let's evaluate log base 2. All right, the base is 2 of 1 over 256. All right, so in other words, 2 to what power will give you 1 over 256. All right, so think about that a little bit. All right, number 2, let's go and solve for x here. Solve for x. In this equation, log base 9, so the base is 9 of x, equal to -3. -3. Alright, solve for x there, and again convert it to an exponential and solve it using the definition of logarithm. Alright, number 3, let's expand this logarithm. Expand ln of, let's say, w to the 5th over x cubed y to the 8th. Alright, expand that into multiple logarithms and post the answers into Blackboard for these 3 questions here. Okay, so until next time then.